Thank you all for being here. I'm the managing director of AR Cloud. I'm going to try and tell you a little bit about what we have been up to the last year, also a little bit about the state of the AR Cloud as we see it, and we're going to go into a little bit of what is next for our organization and for spatial computing in general. First, a little
Our physical reality is changing. The internet is moving off screens and out into the world around us. Digital information, content, and shared experiences will blend into view, impacting every aspect of our lives, culture, and economy. This feature is made possible by AR Cloud technology, which includes machine-readable maps that tech giants and startups are currently spending billions of dollars to create. To reach its full potential, AR Cloud applications, content, and experiences must be accessible and work seamlessly for anyone, anywhere, on any device, and without unjustified restrictions. Above all, personal, private, and sensitive data collection must be limited, compartmentalized, and protected at all costs. We must earn and preserve trust through open and interoperable systems that deliver authentic shared experiences people can rely on. The time to act is now. Join us at the dawn of this new era and help influence how it all begins. Visit openarcloud.org to get more info, join working groups, and get involved, committing your time, talent, and resources today in order to ensure a better tomorrow.
Thank you. So, AR Cloud is a global non-profit organization with a mission to drive the development of open and interoperable technology, standards and data for real-world spatial computing to connect the physical and the digital world for the benefit of all. So yesterday it was a great day for AR Cloud. We were at the spectacular Allianz Arena. You see on the picture, actually Alina was taking that picture from her phone. That's an AR Cloud art piece about privacy, and you can actually go there and experience that. So we were in the telecom lounge with 70 people in the emerging AR Cloud industry, and we also have people from standard development organizations, and we had our members of AR Cloud present, and we celebrated our first year as an organization. We launched at this very event at the October 18th last year. So I'm going to just give you a couple words about AR Cloud in general over the last year. So this year, AR Cloud was talked about. We published our State of the AR Cloud report. You should go and check that out. If you haven't, you can download from our website. Charlie Fink created, in collaboration with a huge, I think Amy as well, was part of this collaborative piece on the convergence of all these technologies into what we also can see as the AR Cloud. There was this great article from Kevin Kelly in Wired magazine about the mirror world. It's the same concept. And one of our partners, Versus, they released their book on the spatial web. And importantly, AR Cloud was talked about, was getting very real. So Google has launched a real end-user AR Cloud experience. Actually, it would have been beneficial if we had like the more advanced version of that for our event last year, because it was really hard to find the entrance to the building. So an AR wayfinding app for that event would have been awesome. So next time we do that, we'll use the AR Cloud. Facebook, they announced their future plans for what they call live maps. It's the same basic idea. Magic Leap at the same time, actually the week before AR Cloud launched in October last year, end of September, Magic Leap described their vision for the Magicverse. It's those Facebook and Google, Magic Leap, they are all walled garden systems as we see it. But there's this interesting thing going on with all these startups. We have UAR, we have Hypergiant, we've got Visualis, we've got Immersal. A lot of companies are bringing something new into this this area. So it's exciting, but there are many unresolved problems. There are no standards. There's this emergence of walled gardens. We have very poor interoperability because of that. And we don't see that privacy, safety, and security is being addressed. We don't see an advanced thinking around the digital rights and the governance of this new technology sector. So resolving these problems is getting more urgent by the day. However, Open AR Cloud, according to our mission, was created to save the day. Maybe with a little help from our friends. So, before we go into how we're going to save the day, we're going to look a little bit about our first year. So, as I just told you, we started here at AWE in 2018. When we did that, we launched our privacy manifesto for AR Cloud solutions. We had also gotten 16 organizations together as founding partners from the emerging industry and also standard development organizations. So we gave until November 1st, that's like a couple of weeks, less than 2 weeks, for people to join in as founding members. And we got a good response from the community. We got 240 individual members and 36 founding partners. So when we were like ready to go, but there were some paperwork issues, so we got stuck with US bureaucracy. We registered our organization in America to try and make a 501c3 nonprofit, and there was this government shutdown, so we were like hung up for a little while. But we were planning to get and gearing up to be operational. In the meantime, in January, you saw that Microsoft released Spatial Anchors, Azure Spatial Anchors. So that's a real AR Cloud technology that you could go and buy and use. There was also the same month no, that's actually that's next month. That was February with a Mirror World article. And that was also the month when we got into business. So on February 12th, the core team, we created a webinar where we laid out how we intend to work. So we described how we were going to set up working groups and what those working groups were going to be like, and what sort of code of conduct and how we envisioned that the working groups should operate. And then it was a well-intended webinar, and a couple of weeks later, we held our inaugural working group sessions. Let me see. Whoa, now we're getting ahead of ourselves. So we had set up 10 working groups, and we had those working groups set up to look at the challenges of AR Cloud computing from many different angles, not just the tech angle. We need also the legal angle, the privacy angle. And I think that's very unique for Open AR Cloud. We're not just doing this single-minded tech thing. So we tasked these working groups to do an initial assessment of the field from their professional perspective. And we soon come up with the idea that we should just aggregate those assessments into a report, and we should present this report to the world. So we planned a symposium, and we got working. So in a few spring months, we worked day and night, a group of almost 40 volunteers. And we got together this state of the AR Cloud that I think, if you haven't read it, you really need to go. And I think this is, at the time, and still, it's one of the best sources to understand this new sector. And we also, this is an overview. We got over 140 pages. This is the first of its kind. And we also presented this in the Ericsson Experience Center in Santa Clara the day before AWE in Silicon Valley. And it was a great great showing of people from the industry. We had really great tech demos. We had edge computing on show. We had some great presentations and also great panel about privacy and security in the era of constant reality capture. So this was a huge and great day for OpenAir Cloud. But we weren't resting on our laurels, is that what you say? Yeah. So 1 year later, one of our working groups had put together a proposal for a standards working group to develop something we call GeoPose. We want that to be a universal standard for geospatial position and orientation. So, and you want to have 6 degrees of freedom. That's important for any kind of AR experience, but also for robotics and for autonomous vehicles. So this is a standard that does not exist, and we created this proposal, and we presented this for a standards organization called OGC. And it was well received, and a little bit later it was put on for public review, and we got feedback from the community. Now it's also on track. It's being voted on as we speak to become a real standards working group by the end of this year. And we got some really key partners who are interested in this standard. So moving along, we see that shortly, not long ago, we saw that Facebook, they announced their vision for this type of technology. No mention of privacy and security, though. And now we're here, and we had this great symposium yesterday, and we are here today to tell you a little bit more about what we're planning for the future. So one thing that wasn't mentioned on this list that happened at our symposium, we partnered with XRSI. So also in this summer, we've been working with them on this XR data classification framework working group to understand the different types of threats and security risks that are involved in AR and VR. And I'm really impressed with the number of very highly skilled people that XRSI has brought. It's just not just people from OpenAir Cloud, but they have the top minds in security collaborating with them. And yesterday they also announced that the National Cybersecurity Alliance had partnered with them to do some amazing projects going forward. So now, what's next? Let me see, how many minutes have I left? 10 minutes? So I mentioned these problems. There are unresolved problems. But OpenAir Cloud has a plan. And we will have one main focus this year. And it's an ambitious plan. There's no guarantee of success. And your contribution will be welcome and needed. And are you ready for the master plan? So, we're going to build an open spatial computing platform. Sort of inspired, it's a bit like the open web platform, but for spatial computing. We call it this, and a new 4-letter word for you to remember. So we'll design and build an open and decentralized platform for real-world spatial computing consisting of standards protocol as well as service and client reference implementations. The work will be done in collaboration with standards development organizations, partners, and other contributors. OSCP provides only the template. Commercial players may use it to implement, build, and run the actual infrastructure as a for-profit service or product provider in compliance with the platform. We have set the goal of demonstrating the core components of a minimal viable version, or a minimal viable platform actually, by the end of 2020. That's sort of like, if you go back to 1990, that was actually when the web platform was created. The idea was from 1989, but that was sort of like a vague and exciting idea on scribbles on a piece of paper and a few notes. But it was actually by December in 1990 that there was a web browser, there was a web server, there was HTML, HTTP, the URL, all of that was in place. So we will also establish a long-term program to iterate, improve, and extend the platform together with the industry, SDOs, and civil societies. You know, that's important because this is one of first thing we do to just get it up, but we aren't guaranteed that the platform that we arrive at by the end of next year solves all the problems the way we want. We need to just test that, and then we need to be able to iterate on that and improve it. So this is a huge, big undertaking. So let's go into a little bit why are we doing all this? So these are the core things that we think the platform should do. This is not on a very technical level, but like the high level. You want to know where you are. So that's the word GeoPose. I described the GeoPose. So you have a highly accurate geospatial position and orientation with 6 degrees of freedom. And you want to give the users or the systems the machine-readable world. So you have the geometry, semantics, the relationships of the physical world near your location described in a machine-readable format. And thirdly, you want to be able to access what is available. You want to be able to summon up experiences, content, applications to do whatever you want based out of this platform. That is where the real thing. This is, with the 1 and 2, that sort of enables an explosion in the economy of spatial computing. Just like the web created this huge economic opportunity for the IT industry. So I think we're actually in the enablement track, and the platform is intended to enable those visions that you see about the mirror world or the spatial web, or what I used to call it, the superverse. I'm trying to get over that. And also, it's important, it's not only used by people, it's going to be used by robots, it's going to be used by autonomous cars, and other technical systems, IoT devices. Okay, here it is. This is the big thing. We list the standards, the protocols, the fundamental services, and the client and service consumer. This is sort of like a parallel to things you have on the web platform. For the standards, you have stuff like HTML and the URL, and you have the protocols like the HTTP. But we have a new set of such things, but for spatial computing. So we have the GeoPose, we have the RML, the reality modeling language. It's not defined yet, but we're looking into existing modeling languages, and we might see if they can work, or we have to maybe make something new or extend something that is there. We want to have protocols for requesting a GeoPose. So from your device or your self-driving car, it can request a GeoPose from a service, and then you also need a type of service that can deliver and respond to your system. So I think this is the minimal viable, the things that are highlighted in white, that's the minimal viable platform for an open, interoperable spatial computing future. And this is important. We're actually not going to build the railroads, and we're not going to build electricity systems for this. We're going to describe the width of the railroads. You know, we're going to tell the world how you can do this in a standardized way. But we want commercial actors to actually be the providers of the services. So you can liken it a bit to the ISPs that gives you access to the internet. You pay for access to the internet. The internet is an open platform, but somebody has to do the job to provide you with a GeoPose, to provide you with the access to all of the content on the spatial web. And so these three items they're like, without, if you don't have all those three, is very limited things. But GeoPose alone, that could enable a lot of new, like a huge number of new use cases, but it's not like a complete platform with only that. But we're very confident if we are able to do this, we are unleashing a new era in spatial computing. This is the start of the new era. So I'm super excited about this. We only, how much time do we have? 9 minutes? We can go into some of the technical details. So this is some future considerations. This is not the part of the 2020 plan, but it's sort of like an obvious thing for a lot of the use cases. They need the high bandwidth, low latency that is being talked about with regards to 5G. It could be something else, you know, but the important thing is that you have this high bandwidth, low latency to be able to do stuff that is, if you have traffic or other things where you cannot wait for a server on the other side of the planet to do something for you. You need to have the immediate computation at the edge. And interestingly, this gives rise to a decentralized structure. So what is both technically optimal is also gives you a distributed computing system. And that gives you the opportunity to try and establish a security firewall around the edge compute. So you run those core basic utility services at the edge. That is what we imagine a few years from now. It's possible today to prototype and test, but it's not really something you can do all across the world, maybe for a few years. We also think that we need to have solutions to have fallbacks if like those blocks looking almost like a Rubik's Cube, they represent an edge compute center, and it might be limited how many services you can run on it, so maybe it's full, and then you need to have a fallback into the clouds. And you want to maintain the security firewall around your edge compute, so you create a virtual edge firewall in the clouds. So that's the idea behind that illustration. Here's a little bit describing how you might use the protocols. So we have this spatial discovery service. So you assume you are already connected to that service, and then you could ask that service, can you give me the list of GeoPose providers? And you get a list back, and your system tells you that okay, there's a match. You are already accustomed to. You have already used the particular service provider that is found on the list, and you don't have to do anything. Or maybe there are new service providers never heard of, and you have to make a selection, and you choose it just like you choose your Wi-Fi or something. But the base case is it goes automatically. Now you have the service. And now you could do a request. You might send an image, you might send some sensor data, you might send... These are things we're going to work on this year to figure out what is the protocol for requesting a GeoPose back. And then you get the GeoPose back, then you can go back to the spatial discovery service again and ask, what is here? What sort of services can I summon at this location? So this is going to be a very powerful platform. Here's also an illustration from our working group. It's not updated with all the names of the services, but there's what you see as the registry. That is the spatial discovery service, and you need this concept of moving between these geographical zones. And there's different content and services available in the different zones. And those transitions needs to be smooth and efficient. Also, we need to look into how to avoid the tragedy of the commons, where everyone do the same work over and over. So by setting up some shared data standards for spatial data formats, there are actually a number of those available that we can build on. and just set up the system that you can access those data. So you're a commercial service provider. So at the end, you're doing something you're getting paid for, but you're actually bundling in and building on data that is provided by other providers, paid or not. So it could be open data, it could be paid data, but they are complying to standard formats. And this is an important aspect. When we're into the topic of standards, we really want to not be these people who just creates new confusing standards. So we are in very close contact. We have partnerships with a number of organizations, and we are also in close dialogue with other standards development organizations regarding our thoughts for our platform. Summed up, the web with its open standards became the most successful platform for flatware. I don't know if you saw the speak by Ori. And it brought the world online. Half of the world's population, more than half, is online now. OpenAR Cloud believes that the most successful platform for spatialware will also be open and interoperable, as well as geographically decentralized. We act on that belief by building such a platform together, starting right now. And we want you to join us. So, with that, thank you very much.